welcome to the deep dive. Ever wonder what huge creatures might have roamed your own area millions of years back? Today, we're digging into the story of Appalachiosaurus. It's this really fascinating predator from, well, ancient eastern North America.
That's right. Yeah, we've been looking at the information out there, mostly the Wikipedia page for Appalachiosaurus, trying to really get a handle on what makes this dinosaur tick.
Yeah, what makes it so interesting?
Our goal really is to, go past just the bare facts and look at the bigger picture, its life, its environment.
Exactly. So our mission for this deep dive is to sort of piece together this Appalachiosaurus puzzle. Where does it fit in the Tyrannosaur family? What does finding it tell us about that lost world of Appalachia? And hopefully, spark some aha moments about prehistoric life, maybe right where you live. Okay, so let's start with the name, Appalachiosaurus. It sounds pretty cool, but there's real meaning packed in there, isn't there?
Oh, absolutely. The name, well, it basically means Appalachian lizard. Simple enough, right? But it connects directly to the Appalachian region.
Right, the mountains.
Yes, but what's really interesting is it's not just the mountains we see today. Back then, late Cretaceous period, there was this whole ancient island continent called Appalachia.
Okay.
And both the old continent and our modern mountains share that name. So it's like a double connection to this specific part of the world.
That's neat. And the second part, Montgomeryensis, what's that about?
Montgomeryensis, yeah, that's the species name. And it's a direct shout out to Montgomery County, Alabama.
Oh, okay, where they found it.
Exactly. That's where the very first Appalachiosaurus fossils popped up. It really anchors the dinosaur to that spot, where we first learned it existed.
So who actually put the name on the map? Who gets the credit?
That would be the paleontologists Thomas Carr and Thomas Williamson. They formally described it, the genus Appalachiosaurus and the species Montgomeryensis, back in 2005. That's when it officially entered the scientific record.
2005. A great context. The name tells a story. Now, that first discovery, how did that happen? How did we first find evidence of this thing?
Well, finding that first specimen, the type specimen we call it, that was key. It was July 1982. A geologist from Auburn University, David King, he made the find.
Whereabouts?
In central Alabama, specifically in the Demopolis Chalk Formation.
Demopolis Chalk Formation. Okay, that sounds specific. What's the significance of finding it there?
Right. So the Demopolis Chalk, it's a rock layer that formed during the Middle Campanian Age. Late Cretaceous. We're talking like 77 million years ago, give or take.
Wow, 77 million.
Yeah. So finding the bones in that layer gives us a really good fix on when Appalachiosaurus was around. Like you said, a time capsule, basically.
And it wasn't just Alabama, though. I think you mentioned other finds.
Correct. Yeah, not just a one-off. Since then, more fossil bits attributed to Appalachiosaurus have shown up elsewhere. Back in 2007, there were finds in North and South Carolina.
Oh,
yeah, from the Donoho Creek and Tar Heel Coachman formations. And more recently, remains from the Ripley Formation over in Georgia at Hanahatchee Creek.
okay, so Alabama, the Carolinas, Georgia. It's starting to sound like this dinosaur really got around in that ancient eastern North America.
That's exactly the picture that emerges. It suggests, a pretty decent range across that old island continent, Appalachia. Each find adds another data point to its map.
Right. Okay, so we've got the name, the finders, the when 77 million years ago, late Cretaceous, and the where eastern North America. Let's get to the good stuff. What did this thing look like?
Okay, yeah, this is where it gets fun. The best skeleton we have, it's actually from a juvenile.
A kid.
Yep. But even as a youngster, it was pretty big, about 6.5 meters long. That's 21 feet.
21 feet for a juvenile.
Yeah, and weighing maybe around 623 kilograms, so what, 1,373 pounds?
Right.
Think like a small car.
Whoa, okay, that's already the decent size.
Yeah.
So what does that imply about the adults? They must have been.
Huge, presumably. Significantly larger, yeah. But the frustrating part is we haven't found a complete adult yet. So its full size is still, well, kind of up for grabs. Leaves a lot to the imagination, picturing the full-grown version.
And even this juvenile, it wasn't a complete skeleton, right? What parts do we actually have?
No, it's partial, but still very informative. We've got parts of the skull, some bits of the lower jaw, vertebrae, parts of the pelvis, and most of the hind limbs.
Okay.
And a key thing, confirming it's a juvenile, are these open sutures in the skull bones. They're like little gaps between the bones that fuse up solid in adults.
Right, right. Makes sense. And I heard the bones weren't exactly pristine after all that time.
Well, yes, 77 million years in the ground takes its toll. Some bones are crushed, likely just from the pressure, fossilization. But even so, the specimen kept enough detail for scientists to spot some really unique features.
Unique how? What made Appalachiosaurus different?
Well, one funny little detail is on its foot claws. There's this unusual small bump or protrusion on the end closest to the body. It's subtle, but distinctive.
Okay.
And maybe more noticeably, this juvenile had a row of 6 low crests right along the top of its snout.
Crests, like decorative. What would those be for?
Could be, yeah, maybe display, communicating with others of its kind, or just recognizing each other. Hey, I'm an Appalachiosaurus too. It's actually kind of similar to another Tyrannosaur, Alioramus, over in Asia. A lot of Tyrannosaurs had some kind of bumps or horns on the snout or brow, but this specific row of 6 low ones is pretty characteristic for Appalachiosaurus as far as we know.
Interesting. Now, the arms,
Yeah.
the classic tiny Tyrannosaur arms. Did Appalachiosaurus follow that trend?
Ah, the arms. That's actually one of the big unknowns. We haven't definitively found any arm bones that belong to Appalachiosaurus.
Oh, really? None at all?
Nope. So some early drawings, which are now, outdated, they guessed maybe longer arms, maybe 3 fingers, but based on its relatives, the big Tyrannosaurids.
Like T-Rex and Albertosaurus.
Exactly. The general thinking now is it probably had the typical short arms with just 2 functional fingers, even though we haven't found the actual bones to prove it for Appalachiosaurus specifically.
So, educated guess based on the family pattern?
Pretty much. You see museum displays updated sometimes to reflect that shift in understanding. Science marches on,
It does. Okay, so maybe tiny arms, but what about the business end? The bite. Was it powerful?
Oh, definitely. Yeah, based on the skull structure, the estimate is a bite force around 32,500 newtons.
Which translates to?
About 7,193 pounds per square inch, PSI.
Wow. Okay, that's bone-crushing territory.
Absolutely. More than enough to make short work of its prey.
Yeah, you would want to be on the receiving end of that. Okay, so we're getting a clearer picture. Mid-sized predator, late Cretaceous, distinctive snout crests, powerful bite. Let's talk family tree. Where does it slot into the big complex world of tyrannosaurs?
Right, its classification. This is important for understanding its significance. So Appalachiosaurus is a tyrannosaurian theropod, and specifically, it's considered a basal member of a group called Eudiranosauria.
Basal, meaning?
Think of it like being closer to the base or the root of that particular branch on the family tree. It means Appalachiosaurus was relatively close to the ancestors that eventually led to the more advanced or later tyrannosaurids, like T-Rex itself. It's kind of foundational within that Eudiranosauria group.
So, not quite in the main Tyrannosauridae family, but just outside it, or maybe an early member.
Well, that's where things got interesting initially. Some of the very first analyses, phylogenetic analyses they're called.
The tree-building things?
Exactly. Some early ones actually placed it within Tyrannosauridae, specifically in the Albertosauridae subfamily. That's the group with Albertosaurus and Gorgosaurus.
Okay.
But the original paper describing Appalachiosaurus by Carr and Williamson, they actually found it was a more basal tyrannosaurid, branching off before the main Tyrannosauridae family even formed.
So conflicting ideas early on. Why the difference?
A big part of it was likely the data available at the time. Those early analyses often didn't include some important Asian tyrannosaurs like Alioramus or Electrosaurus, or even Eotranus from England.
Because they weren't known yet or fully understood.
Pretty much. And also some really early tyrannosaurs like Dilong and Guanlong from China, they hadn't even been described yet. Adding those pieces later really changes the shape of the tree, you see.
Right. You need all the relatives to figure out the relationships properly. It's like trying to build a family tree missing half the cousins.
Exactly. So more recent studies, like one mentioned in the source by Lowen and colleagues from 2013, use more complete data sets.
And what does that 2013 study show? Can you sort of walk us through its placement on that cladogram, that family tree diagram?
Sure. So imagine the tree. You've got early branches with things like Dilong. Then you move up and you see another dinosaur from eastern North America, Dryptosaurus, branching off. Appalachiosaurus appears further up that main line, kind of.
Closer to the later guys.
Yes. It's positioned as what we call a sister taxon. Basically the closest relative to a group that contains Alioramus, that Asian one with crests, and the entire Tyrannosauridae family.
Okay, so Appalachiosaurus is more closely related to T-Rex and its immediate family than it is to Dryptosaurus, even though both lived in ancient Appalachia.
That's what the analysis suggests, yeah. It shows Appalachiosaurus is significantly more derived, more evolutionarily advanced, you could say, than Dryptosaurus. It highlights that you could have different evolutionary grades of tyrannosaurs living in the same area.
Wow, that's fascinating. Evolution isn't just a simple ladder.
Not at all. More like a very bushy tree with branches going off in different directions.
Okay, one last interesting tidbit from the source. Something about an injury, a pathology.
Yeah, a little glimpse into its life. The known skeleton, the juvenile one, it shows two tail vertebrae fused together.
Fused. How does that happen?
The most likely cause is some kind of injury, maybe a blow to the tail, maybe some disease, but probably trauma. The bone heals, but it grows across the joint, fusing the two bones.
Ouch. A tough life for a young dinosaur.
It could be, yeah. But it survived the injury, clearly. It's just a little mark left behind.
Gives it character. Okay, let's try and wrap this up. What are the main takeaways about Appalachiosaurus?
I'd say the key things are it was this unique, medium-sized tyrannosaur from Late Cretaceous, eastern North America, about 77 million years ago. Critically, it's a basal eutyrannosaur.
I mean, it helps us understand.
It gives us vital clues about the evolution leading up to the big, famous tyrannosaurs like T-Rex. It's an important step on that evolutionary path.
And crucially, we have to keep remembering it's based on a juvenile, right?
Absolute critical point. Yeah. Our whole picture is based on this one young individual. It tells us a lot, but it definitely leaves big questions open about what a full-grown adult looked like, how big it really got, maybe other features it developed.
We need an adult fossil.
That would be the dream, wouldn't it? An adult Appalachiosaurus would be an incredible find.
Yeah. It really makes you think, doesn't it? Picture the eastern U.S. 77 million years ago. Completely different. Ruled by animals like this. What else is still out there, hidden in the rocks under our feet in Appalachia?
Yeah. Makes you wonder.
What other stories are waiting? It's a great thought to ponder. Thanks so much for walking us through this.
My pleasure. It's a fascinating creature.